we are starting our work with operations and square roots, and we're going to begin with addition and subtraction. Here's the good news. You have been well versed in the basic idea of adding and subtracting roots because you've added and subtracted fractions before, and you've combined like terms before. The rules that apply for adding and subtracting fractions and combining like terms are the same rules that apply for adding and subtracting roots. Okay, it just look a little bit different. For example, can we add 5/8 and 2/8?
Yes.
Yes. Why? What about this allows them to be added? Noah? They have the same denominator. And when we add them, what actually gets added? The numerator. And what stays the same? The denominator. So 2/8 or 5/8 plus 2/8 would equal 7/8. Okay. The next one, 3/5 plus 7/10. Why can't we add them the way it's written? Why can't we add them the way it's written? Beckman. Because the denominators are not the same. If that's the case, what options do we have? Kylie?
We can either simplify the 7/10, which isn't possible, or we can find the common denominator of 5/10.
We basically have to see, is there a way that we can get common ones?
Yeah.
Right? And sometimes you have more options, but in this case, probably the easiest one, most efficient, multiply 3/5, both 3 and 5 by 2. That gives us 6/10. And now we can add them because the denominators are the same. When we actually add them, the numerators get added and the denominator stays the same. 13/10 is our answer. Okay? And similar deal with 8/9 minus 2/27. We're subtracting. We also need those common denominators. We can do this by multiplying 8 and 9 each by 3. To get 24/27 minus 2/27. Now they're able to be subtracted. The denominators are the same. And so 22/27 is our answer. Okay? Fractions. Denominators have to be the same. Denominators stay the same. Okay? Like terms. How can we combine 4x and 10x? Burgess, how can we combine 4x and 10x? You have 4 x's, you get 10 more x's. How many x's do you have in total? 14 x's. And the reason why we're able to combine these terms is because what?
It's the same variable.
Same variable. Okay? Does the variable change when we combine them? No. What changes? The coefficient. How many we have, right? 4 x's and 10 x's, total 14 x's. What's the second one? 12n minus 7n. 5n. Again, the n doesn't change, just the coefficient, how many we have. 6x plus 2y. Can we add those together?
No.
Why not?
Because they're not the same coefficient.
They're different variables. Is there anything, Jack, warning for you, is there anything we can do to rewrite this so that we can combine them, or are we just stuck? We're just stuck. Okay? There's no way to make an x into a y or a y into an x. Okay? We just have to keep them separate. Damien?
Can you write 6x 2y?
You can't write 6x to 2y, because what that means is that you're multiplying 6 times x times 2 times y, but we're adding them. Okay? So we wouldn't be able to do that. The process for roots is exactly the same idea. Elliot?
Wouldn't it be 3x plus y because we can simplify it?
You can't simplify the 6 and the 2 there. They're not a fraction, right? So you can't like cancel anything out. And the way the order of operations works, we have to multiply before we add, right? But because we don't know what x or y are, we can't do the multiplication. So we have to leave it as 6x and 2y, and therefore we can't add them in any way either. We can do it here because of things like the distributive property and such as that, the combining like terms there. But with the different variables, there's nothing we can do. Okay? It was a fraction, potentially simplifying, but not the way it's written there. Right? So then we get down to roots. And if I ask you for 3 root 5 plus 8 root 5, just thinking about what we just talked about with fractions and combining like terms, what do you think this would be? Burgess, what do you think? 3 root 5 plus 8 root 5. Just what's your gut tell you?
11 root 5.
And you would be correct. Okay? Just like in fractions, these roots have to be the same. And when we add them, they don't change. Because what these coefficients tell us are how many root 5s we have. You've got 3 of them. You get 8 more of them. Total, you have 11 root 5s, right? So just like numerators of fractions, those coefficients do not change. They get combined, and the roots stay the same, right? 12 root 7 minus 9 root 7. What would you guess? 3 root 7, and you would be correct. Again, just like fractions, that process holds. Those roots have to be the same. The coefficients are what change. 10 root 10 plus 13 root 10. Jack.
10 root 10, that would be 26. Oh, wait, no, sorry. Minus 3, 23. Sorry, 10. 23 root 10.
23 root 10. Okay. 5 root 2 plus 6 root 6. The roots aren't the same. And so, like fractions, we have the opportunity potentially to make them the same. And the only way we can make them the same is by simplifying them. Okay? We can't multiply this one by root 3, because then what would we have to do to 6 root 6? Multiply by root 3 also, right? And it says sometimes we'll just multiply the 5 root 2 by root 3. If we do that to get 5 root 6, well, now we've just changed one of the values without changing the other one. So we have to multiply this by root 3 as well, which would give us 6 root 18, and we're in the same situation we were just in, those unlike roots. So the only way to get like roots is by simplifying. Can you simplify root 2?
Yeah.
No. Can you simplify root 6?
Yes.
No. It doesn't have a perfect square factor. Noah, warning for you. Unkind. Okay? Think back, that's why CO61 is a PO, right? Everything else stems back to that simplifying piece. There's nothing we can do with the root 6 because we need that perfect square factor. So just like our above example where it was, what was it, 2x plus 3y or whatever it was? Whatever it was, we're stuck. We've got different roots. We can't simplify to make them the same, so there's nothing that we can do. Okay, Catherine? Yes, if there are further examples below, like 5 root 2 plus 4 root 8, we'll talk about one that you can get like roots with.
What do you do?
Okay, we'll talk about that. Alex?
Never mind.
Okay. 11 root x minus 2 root x. This would be the answer, right? That is already in simplest form. Just like if I asked you to simplify 2x plus 3y, you can't. They're different variables. You can't simplify this because they're different roots, and you can't simplify either of them. We're not factoring. This would just be in simplest form. Right? So that would be your final answer. Anthony?
9 root x.
9 root x. We have 11 root x's. We subtract 2 root x's. Because those roots are the same, even though it's a variable, we have 9 root x's. Okay? So, now, let's move down a level here. What is going on with Microsoft Word today? And we have that... all right. 5 root 2 plus 4 root 8. Right? Can we add them the way they are written? No. One's root 2, the other one's a root 8. Right? So then the question that you have to ask yourself is, can you simplify?
Yes.
Yes.
What can you
No.
simplify?
Yes.
Ellen?
The 4 root 8.
The 4 root 8. So this isn't anything new, right? You did this exact thing back in CO61. What does 4 root 8 simplify to be? Damien?
4, 8 goes to 4, 2.
Okay. We can break down that root 8 and the root 4 times root 2 because it's got that perfect square
And
factor.
then the root 4 turns into 2. So that would be 4 to root 2.
Which we can now multiply the 4 and the 2 to get 8, right?
Yeah.
So we have 8 root 2.
Yes.
Now can we add 5 root 2 to 8 root 2?
Yeah.
What do we get?
30.
13 root 2.
Thank you.
13 root 2. Right? So the process for getting like roots when you don't have them involves simplifying. Can you simplify? Okay? Can you simplify? Yeah.
I'm stuck on the next one.
The next one, 5 root 11 minus 12. What would this 12 have to have in order for us to be able to combine them? It'd have to have a root, right? Ideally a root 11, or something that would simplify to give us a root 11. This example in variable terms would be like if we had 15n minus 12. There's nothing we can do there,
Yes.
right? One has an n, one doesn't. We can't just give the other one an n. There's nothing to multiply, simplify by. We would be stuck there. This would be in simplest form here. Elliot.
Would you want it to be 15, 11, 12, 242, so that you can factor it into 121, 2, and then you square it with that to 11? Oh, wait, never mind, because that would be a positive. Never mind,
Are
sorry.
you just,
Because I get that would be 11. Square 11. Sorry.
I was lost when you said.
What is he
Say
saying?
it again, what are you-
No. If the 12 had like a root 44, Joey, if the 12 had like a root 44, that would work because we could factor out a root 11 from there. But we can't give it one, right? And so we would be stuck in that expression there. Jack.
Can I do the next one?
Sure. What do you got?
Alright, so you simplify the 50 to be 25 and 2.
Okay. So starting here, we're going to simplify root 50 to be root 25 times root 2.
Alright, then you simplify the 25 to be a 5. Put that on the outside of the square root and then multiply that by 10 to get 50 root squared.
50 root 2.
50 root 2. Yeah.
Okay. All right. Good. Good.
Then for the next one, it's you simplify 18, maybe 9 and 2. And then you simplify the 9 to be a 3 over 2, and then multiply that by negative 13, which is negative 39 minus 50. Which equals like 11 or 12 or something.
Okay, chill.
Woo! Good job, Jack. Start to finish. Yeah. Basically, what Jack did here, right, was he took his root 50 and he simplified it into 25 and 2, 25 being that perfect square factor. The root of 25 equals 5, right? When you combine that with our coefficient is how we got that 50 there. So 50 root 2. Okay? And then our negative 13 root 18, the root 9 and 2, that's our perfect square factor. The root 9 becomes a 3, which is combined with our coefficient 13 to get negative 39 root 2. And 50 root 2 minus 39 root 2 gives us 11 root 2. Okay? Like I said, the process of fractions and the process of variable terms is the same. Okay? The process is the same. Obviously, it's a little bit more complicated with the simplifying of the roots, but if you get the idea, Damien, Jack, others, of the like roots, similar to common denominators, that's what's going on here. Questions on this? Okay, here we go. Let's see what the next page has in store for us. Oh, that's right. It's not going to let me scroll that way. For homework tomorrow, I'd like you to do these first 6. Okay? How do you do it? You do it just like you literally told me to do on the last page, Jack. You don't remember what you just said? Okay. You're looking for simplifying each root, right? Getting those common roots. Sure. How would you simplify the root of 20, Beckman? Not root 65, no. How would you simplify root 20, Beckman? Okay. The root 4 being that perfect square, right? And so what does that break down to be?
5 root 2. 5 times 2.
2 root 5.
So 5 root 5.
Okay. And then how would you simplify the root of 45?
9 and 5.
Right? Root 45 is 9 and 5.
3.
9 becomes a 3. We have that root 5. And so what is our final answer, Vince? 5 root 5. Okay? So for each of these, you are looking to simplify to get that perfect square factor, get those like roots, and then add them similar to fractions. Coefficients are what actually get added, and the roots stay the same. Okay? Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Elliot.
Factors of 54.
Factors of 54.
7.
7 is not going to 54.
Right. 9 and 6.
9 and 6.
Good try. Get her next time.
And there are more, but I think that's the one you want to use. Jack,
Go over the third one.
what's your question with that? No, you can do this.
No.
This is, I mean,
It
it's.
makes sense till you have variables in there.
We're not doing the variables though. You're only doing these first 6. Don't worry about the variables. Just do the first 6.
I'm worried about them.
Don't worry about them.
I'm worried.
Lisa,
I got three.
I am just confused on how to like simplify
you're looking for those 2 factors of the root, and one of them's got to be a perfect square. Like 15 and 3 also multiply to be root 45, but we don't want to use 15 and 3 because what can we do with those? Nothing. 15 is not a perfect square, neither is 3. Right? So you want that perfect square factor so you can simplify that down further. So which one in particular are you stuck on right now? Lisa, what multiplies to make 24 that includes a perfect square? Okay, so why is that the one you want to use? Okay, so then you've got your coefficient of 15, right? You're using 4 and 6. So root 4 times root 6, right? And then where do you go from there? Where do you get root 20 from? Well, we're not going to multiply 4 and 6 to get 24 because that's where it just came from, right? Why do we get that perfect square factor? It's because this 4 can become a 2. That when you combine that 2 with our coefficient of 16, allows us to get a new coefficient, 30 times root of 6.
I'm already done with the first one.
Okay? All right, these 6 for tomorrow. That's all I have. I gotta let you go.
Don't forget